Hey everyone. So next we're going to be talking about blocks. So blocks are really just chunks of code that are executed, but based on something, conditions, as whether something is true or false, or if we try to do something and it fails, then there might be a chunk of code that gets executed instead. So it's just these sort of sections of code that don't always execute, but rather they execute when something tells it to. All right. So it's a very broad definition of what a block is. You'll see that there's lots of different types, and that's why it's kind of hard to define just blocks in general, because there's so many different reasons why they would exist. Mostly we're going to be talking about logic, so kind of if-else statements. We're going to be talking about the try-except statements, and we're going to be doing loops, which loops are also blocks, right? So it's a chunk of code that gets executed again and again and again until some condition is met, or whatever. Right, so that's kind of generally what we're going to be doing now, but let's start with a very simple one, which is just if blocks. So we're going to be doing all the logic. So let's create two variables. So I'm just going to call it A and B. A equals 3, B equals 5. And an if statement or an if block in Python is really simple. We just type if. We don't have to, within like in Vex where we open it with brackets or anything, we can literally just type if and then whatever statement we want and then a colon. So in my case here, I'm going to say if A equals B colon, and then inside here. So there's a colon at the end, we hit return or enter to go to the next line, but we cannot just type whatever else we want to do immediately. We have to tab in, we have to indent this block, right? Otherwise it will throw an error. Python expects indenting to designate where the block begins. And then here I'm just going to do a simple print statement saying this is true. Okay, so it will only print this if it is true, all right? And then if I click apply, we will see that nothing prints, right? So I used equals equals. We need to be very careful that we do not use just a single equals. This should be familiar to most of you if you have ever used any Vex, and a lot of other programs use this. Equals equals is a comparison. So single equals is setting, so B is equal to 5. We are telling it now that B must be equal to 5. This is a question. Double equals is a question saying, is A equal to B? Not B must be set to be equal to 5, right? So this is writing the data, this is questioning the data. So it's saying, is 3 equal to 5? No. If this is true, it's going to run this block of code, whatever's here. And let me put just something outside of the block to show you the difference between the block and then the next line of code. So this indented section, whatever we do over here, will be executed only if that condition is passed and is true. But this statement is just the next line of code. So regardless of whether this executes or not, this is going to execute because this is just, this is just our code continuing. So if I hit that, you'll see it prints end, but it does not print this is true. Now there are a couple of different logic statements, really simple ones. It should be intuitive. You can ask if A is greater than B, which obviously it is not because it's 3. We can ask if it's greater than or equals to, and it must go that way around. If you put it equals to greater, that will report an error. It's the greater than or equals. So equals always comes at the end, unless it's obviously equals equals. Then there is less than. So less than B, well, in this case, this is the first time this has actually been true because 3 is less than 5. So this is true, and then you'll see it still prints end. Also, we can say, is it less than or equal to? And that is also still true. Okay. There is another type of comparison, which is to basically compare whether an object is the same object. And that is the is statement. Okay, you'll see it comes up as a different color to show that it's a special word in Python, not just just random text. And this function's where it's basically asking, are these two things referring to the same Python object? So you'll see here, if I put 3 and 3, it's actually going to return true. But this is because the integer 3 can almost be thought of as one kind of object, you know, and both of these happen to be set to be the same, right? But generally you do not want to use it in this way. You don't want to use it to check values and say, is this value equal to that value? If you're doing that, you want to use equals equals. More so is used for whether something is the same object. And obviously integers, it's a bit more difficult to sort of understand that is an object. So let's create a list. I mean, let me create a list that's 3, 5. And then this one is 3, 4. And now we're saying, is A B? Okay, so is A and B the same Python object? Now, obviously this is going to be false. This looks like it should be false because they're not the same value. But what if I set this to be 5? So now they are the same. If I hit apply, you'll see it does not return true, right? It's still just printing end. Because it doesn't matter that these have the same value. This was initialized as a list, and this is initialized as another list. They do happen to have the same items in the list, but it doesn't matter. This, on sort of like in memory, it would have like its own little ID, right? And this, although it looks identical, has its own ID. Okay, it's almost like saying twins, identical twins. They may look the same, but they are not the same person. So that is the same here, saying like A and B are two different lists, even though they have the same items. Now, if we set A equals this and then B equals A, so we are actually taking this list and storing it in two different variables. It's stored in A, and then we're calling that and storing it in B as well. It doesn't take up twice as much memory. It's just two different variables, so it's almost like an alias that's referring to the same thing. So this is the equivalent of having a person that maybe has a nickname. Okay, so A is their name, but B is their nickname. But are they the same person? Is Stephen the same as Steve? But it's the same guy, right? It's not a different Stephen and then like a different Steve. Like it is just one guy. Some people call him Steve, some people call him Stephen. That would then be true. So is it the same object, or is it just the same value? And so in this case, A and B are the same object, and therefore it is true. Whereas when they had the same value but a different name, and they are actually different objects, that is more like, twins, that just do not have, even though they look the same, they are not the same person. They have a different name, they have a different ID, and so on. Okay, so that is the is. There is also is not, which is just the opposite. So it's just saying if it is not the same, then it will return true. So in this case, it returns true because A is not B. That's why I like Python, because it literally reads like English sometimes. Like it is just so easy to understand. It's very intuitive. If A is not B, then do this. Well, A is not B, but now, of course, if we make A is B, then no, A is not B, so don't do this. Right. So those are our logical tests. There is another follow-up to this, which is we can link multiple statements together. So we can ask if A is B and A equals B, right? Or A greater than B, or something like that. Okay, in this case, probably that doesn't make sense because now it'll almost never be true. So let's come up with a different value. So let's go back to a simpler, let's go back to a simpler version. So we'll just say, we'll call this 3, 5, and 6. And we're basically going to just say if A is greater than B, or maybe A less than B, and C is equal to B, then this will be true. right? So you can do two different statements. It could be whatever you want, and it can be multiple. You can then have and then put a third statement, and so on. So now in this case, it's not true, so it doesn't print true. But if we make B and C equal, and 3 is less than 5, then it's going to be true. All right. So you can stack up multiple. We've got and. We've also got or. So this will be true only if one or the other is true. So then if this was 6, this will still return true, because this is true, this is false, and it's essentially taking the maximum of those two. So you could have 3 or 4 stacked up and all of them are false except for one. It's still going to execute the block of code, because all it needs is one of them to be true and then it will do it. Whereas if you use an and, then they both must be true. And if there are multiple ands, then they will all have to be true. Okay. You can also link them if you really want to get complicated, where you've got ands and ors and everything all linked up. And depending on which ones you want to be, inclusive or not, you can use brackets to kind of say, well, this and that must be true, or this third statement. So it's like, if these two are both true, then this will execute. But even if they're false, if this one is true, then it doesn't even matter what these values are, right? And so now it's not, because A is less than B, so that one is true. But C does not equal B, therefore this is false. And because they're joined with an and, this entire bracket is returning a false value. But then this one is also returning false, and therefore, because it's or, if both are false, then it's not going to execute it. If we just made this 12, even though C does not equal B, A is less than B, this whole thing comes out false, but this is true, therefore it will be true. And now if we hit apply, you'll see it prints this is true. Okay, so lots of ways you can kind of link these together. In addition to this, we have a further statement that we can include with if, which is else. This is essentially saying, if this is true, then run this block of code. And if it's not true, then instead of just doing nothing, I would like you to actually do a different line of code or block of code, right? So we would say this is false. Or we could do whatever you want in here. Keep in mind, this is not a single line. It can be a whole block. So we could say like D equals 5. Over here, we say D equals 10. And then we can print D, right? So you're able to not just print or do one line, you can do multiple lines within, that's why it's called a block of code, right? And as long as it's all indented to the same level, it's going to treat that all as one chunk of code that it executes, whether or not it's true or false, okay? Now, this statement over here is true, therefore it's doing this. This does not get executed at all. If, however, we take our C back down to 6, right? So none of these are true, because even though this is true, it's included in an AND statement with that. So it's going to come out false. So then it executes this backup code that says, okay, so that whole statement is false, therefore do this. Now the else statement, you'll see it's just the word else and a colon. It does not have another statement next to it because it is linked with this. It's like, it's basically saying the same statement, but the reverse. Is this false? If that's false, then do this. Okay. So that's our else statement. Now we have another one called elif. Now elif is kind of a short way of essentially saying else if. Okay, so you're saying try this. If it's true, then do this block of code. But if it's false, then do another test. And if that one is true, then execute its block, and then if it's false, then go down to the sort of the else statement. So usually you'll have an if, then an elif, then an elif, and as many elifs as you want, and then an else at the end, right? So this one does require another statement because it needs to test another statement. So I'm going to use the short form, the correct one, so elif, right? You'll usually see elif, not else if. And here we could say something like if elif maybe a is greater than 8, then do this other thing. Okay, so then we'll just say elif is true, right? And maybe we'll give d something, so d equals 8. Okay, so in this case, the first statement was false, so it goes to this block. A is not greater than 8, so this one's also false, so it doesn't do this one, therefore it will do this. However, if we now make this equal to 9, so it is A is not less than B, so this is going to be false, so therefore this whole thing will be false. C is not greater than 10, therefore this entire statement is false. So now we go to the second statement and say, well, is A greater than 8? Yes, this is true, so it's going to execute this block, and it is not going to execute the else block, okay? Because it's only going to do one of these blocks, right? So it now gets caught by the elif is true, and it makes d equal to 8, so then when we print it at the end, it is now 8, okay? So it will only execute one of these. That, if that one's true, that if that one's true, and then right at the end, if none of those are true, then it's going to do the else block. Of course, the else is optional. You don't have to have it. If you don't have it, it will just do nothing. So none of these blocks will execute if there is no else statement to catch them. All right. So obviously that is now true, but let's go back down to that, and you'll see that it just does end and then tries to print d. Now it's funny because d has been initialized as a value because we've been running this code, but actually in this case it's nothing's overriding it. So here we really should have a d equals maybe none, so that it gets overwritten by these blocks of code. So we initialize it up here, and then in this case now it's saying, well, d has not been overwritten with anything, so it's got a none value. All right. Okay, so that's if, elif, and else. Now I just want to mention before we end this in terms of the blocks, well, the if-else's, that you cannot have an empty block. So if while building the code you find that you are wanting to, you know you probably want to do an elif or an else statement, but you're not actually sure what you want to do yet in that block, you can't just put in an if and then an else and leave this block blank because you're going to come back to it and add something later. You need to use the word pass. It needs to at least do something. So pass is basically just, it sounds funny, but pass does nothing. It just passes through. But at least it is executing a line of code. The block is not empty. The block has something to do. It's just that what it's doing is a nothing statement. Okay, so it just does nothing. So this will work, but if you removed pass, it's going to error and say you need to indent the block, because it's, when it sees nothing, it's going to assume that there's no indent. In fact, even if I indent there with nothing after it, it still doesn't count, right? So you have to use pass. And then you can come back to this and replace pass with something else, okay? It's also useful in other ways, because then you could say, well, maybe you want, if this is true, to do this, but then there's another sort of condition you want to check, and in that, if that is true, then you actually don't want to do anything. But if this is true and the other one is, sorry, if both of them are false, then you want to do some third thing. So then you could say elif c greater than 8 pass, and then over here you want to say print this is false. Okay, so now we're hitting the, so this is false, therefore it'll do this. But actually if this is false and c is greater than 8, then we're going to do pass. So in other words, we're going to do nothing. So we're just going to print end, and we're going to print none, because this was initialized as none and not overwritten in this block. Okay, so I hope that all makes sense. In the next one, we're going to talk about try except. So I'll see you there.